Welcome to Dreamacademia. So, for those who don't know what is Dreamacademia, let me tell you that Dreamacademia is a platform where we provide quality education for students with the help of the latest technology. So, basically, we are just making some educational content for those students who are preparing for WBJEE, JEE Mains, JEE Advanced, NEET, and those exams. So for student we have a Telegram channel, so if you have any doubt on your studies or if you stuck on a problem, so you can just post it on there, and the link of the Telegram channel is in the description box down below. So you can add to our Telegram channel and post your doubt, and we will help you and we will give our level best to resolve your doubt. So let me give you a brief introduction about myself. So I am Tapas Mondal and I'm pursuing my bachelor's in engineering in mechanical engineering from Jadavpur University, and here is my social media account. So this is my Twitter account and this is my Instagram account. You guys can follow me on there if you just stay connected with me more personally. You can follow me on there, right? So let's dive into our topic. So today we'll discuss about a very important topic in physics, which is work, power and energy. So basically you need to know that this is a very basic chapter, right? So this is very basic chapter, and you can say that this chapter is very much useful almost everywhere in physics. So if you just go to electrostatics, those term work, power, energy will arrive everywhere, right? So in order to master on that topic, first of all you have a good command on this topic. So this is a crash course, right? So we will just see some formula and go through some numericals. We'll not deep dive into the topic. So if you have any difficulty in this chapter or in this topic, so you can go through our year-long series, or you can just read books, so um, to to boost up your preparation. So in this because we have a few days left, so we need to do some boost up series like that. So we are launching this crash course, right? So we will see some formula and numericals later on. Okay, so let's see those stuffs. So first of all, we know that kinetic energy is formulated by this. So we all know that a body which is in rest and a body which is in motion, let's say the mass of the body is m, and this also has a mass of m, right? And this is in motion and this is not in motion. So you can always tell that this will have more energy than this body, right? So you can always say that, right? This body will have more energy than that of this, because it has no motion and it has a motion. So due to its motion it will have a kinetic energy, and this is formulated by this, and it is a scalar quantity. As you can see from that, there is a dot product, right? So it is a scalar quantity, so it has nothing to do with the direction. It has only has some magnitude to consider. It has nothing to do with the direction. Next one is we have work done, right? So work done is formulated by this, that is F dot dr, and if you have more combination of F dot dr, you can just integrate both. You integrate whole stuff by doing integration, right? And this is also a scalar quantity. It has a magnitude only, and it has nothing to do with the direction. So you might think that force is a vector quantity, right? And displacement is also a vector quantity. So how can it be work done is a scalar quantity? So you need to know that the dot product between two is a scalar quantity. So the work done is consisting of force and displacement, so which is we can get it by the multiplication, dot multiplication. So that's why it is a scalar quantity. So it has nothing to do with the direction. It only has magnitude. Okay, so next we have power. So power is what? Power is nothing but rate of change of, so you can say, right, from this thing, right? So you can say that it is a rate of change of work done with respect to time. So again you can say it like that. So what is W? W is F dot x, where x is displacement, right? So you can differentiate like this. If let's say F is a constant quantity, so this is a F is a constant term, so pull out the system, the force remain constant. So if you integrate this, then it will comes out to be dx upon dt. So we have done it wrong, right? So we're integrating with respect to time, we're not integrating with respect to displacement. So we're getting this, so f dx dt. So what is it? Dx dt. Dx dt is nothing but rate of change of displacement, which is what? Which is velocity. So we can formulate power by this also, F equals to F dot V. Okay, so hope you understand it. Now later on, so there is a spring, right? So if you compress a spring, so first of all it is in the initial position, and if you just apply some force and you compress it like this, let's say you compress it like this. So let's say I am compressing up to this position. Okay, so I am compressing up to this position. So then what will happen? Then let me draw it more clearly. Okay, so if you compress that block by applying some force, then what will happen? Then this spring will just come together and it will have a tendency to move backward, right? And it will have some internal energy to force to move that block backward direction, right? And this energy is called the this is what? This is the total internal energy stored in that spring. And we can formulate that stuff also, right? So, and if we apply this force, there will also have a force which will be directly proportional to the displacement that the block get, right? And this is equals to, this is proportional to the displacement. So moreover you push that block, and more the distance it will travel, the force you will just feel will be greater. Okay, so it is equals to x, if here is just x. So if you do like this, so where here you can see that there is minus negative sign is coming off. So this is what? This is nothing but the direction is opposite to the applying force. Your this is the opposite to the force that you are applying. Okay, so we know that a work done equals to F dot dx, right? So we can do it. Here if we get F is as, okay, so first of all initially it was in x equals to 0, and then later on it came to x equals to minus a. So we can integrate it. So if we integrate from x equals to 0 to x equals to minus a, we will get minus k x square upon 2, right, from 0 to minus a, and we will get minus k x square upon 2. Sorry, this I have just write it from there, and there will be a minus sign, right? And you know what, this minus sign has no significance cause so this will be w. This minus sign has no significance cause it is a vector, it is a scalar quantity, the energy which is a scalar quantity, so it has nothing to do with the minus sign, so we can just neglect that minus sign from there. Okay, what we are getting from there, we're getting a work done, right? So we're not supposed to get a work done from there, we're just supposed to get energy from there. So what I have done wrong, so F is force and work done is F dot dx, and if we integrate, okay, so this total work done is will store on the spring as the total internal energy. So this is what, and you know what, the dimensionally work done and internal energy or energy is same, so that is what we get. So this is the total energy stored in the spring. So now let's move into another key point, which is potential energy, right? So potential energy is the total energy due to its gravitation. So here we will only discuss about the gravitational potential energy. There are few kind of potential energy, so we will discuss about gravitational potential energy here. So whenever I pronounce potential energy, so think that I'm just talking about gravitational potential energy. So whenever a block, whenever a man or something, anything, so they have some height, they will have some potential energy. And you know what, potential energy is not that energy which you can calculate as such, so it can be compared with respect to another body, right? So you can calculate it, but it is very rigorous to calculate. So we will do just comparing with other body, or we'll make some assumption that the lowest end or some end as the zero level of potential energy. So here we will consider, okay, my cursor is not moving that fast, so here we will consider this lowest level as the zero level of potential energy. So there P equals to 0. Let's say that, right? And it has a height of 25 meter. So at that point the potential energy will be what? That will be the total mass of the total body, total this body. So let's say that the mass of the total body is m into g is what? G is the gravitational what is it? G is nothing but the gravity, right? And h is the total height, which is 25 here. So this is the total potential energy at this point, right? Now whenever this is what? This is a roller coaster, right? This is a roller coaster. So whenever this will come to that position, so that position it has a height of 5 meter, right? So it will have a potential energy of mg into 5. So this is the potential energy. So this is not a heavy stuff, so this is a pretty much simple stuff, right? And this is how potential energy is formulated, mg into h. Now moving later, we are talking about potential and the kinetic energy, and the summation of two energy, potential and kinetic energy, in a mechanical system, and where no non-conservative force system is acting, on that system, the kinetic energy and the potential energy summation is a constant. So there will be many questions where you will get that potential energy and kinetic energy, and you have to just build some scenario so that you can say this, like, okay. But this may not true in every scenario, so there will be certain scenario where this is not true. So let's think about a bomb, right? So this bomb initially has no velocity, this is in rest, and let's say this is a zero level of potential energy, and this is the total zero level of potential energy. Okay, so due to it is a zero level of potential energy, it has no potential energy, so the summation of the kinetic and the total potential energy here is 0. So here ek plus pe equals to 0. But when this bomb blast, right, so this bomb will turn into thousand or millions of tiny pieces which get some speed or motion, and due to that speed they will get some kinetic energy, and this particle may get some height as well. So their kinetic and the potential energy is not 0, so they are having some value, right? They are having some positive value. This is not equals to 0, and here potential energy is not equals to 0 for that tiny particle, for those particle, right? So what happening? So you may say that the statement conservation of mechanical energy is not true, but dear, here we are saying about the mechanical system, right? We are saying about the mechanical system and non-conservative force system, and there are a lot of energy. The energy can convert it into one form of energy to another form of energy. So here what is happening, this bomb has a chemical energy, right? And this chemical energy is converting into kinetic energy and the potential energy. So, and there are many other energy is also arising, like thermal energy, which you will not talk about that. So this is what is happening, right? This chemical energy is converting into kinetic and the potential energy. So you have to just conscious about before you applying those stuffs, right? You have to be careful. Okay, so now we'll do some numericals about this topic, and by doing numericals your concept can be solidified, and if you do numericals positively and more carefully, then your concept can be clarified easily. So we'll see some numericals. Okay, so this is the first question. What does it say? Okay, so an explosive of mass 9 kg. Okay, this is a 9 kg explosive. Okay, the mass of this is 9 kg. Okay, mass of this is 9 kg, and it is divided into two part. One part of mass 3 kg moves with the velocity of atto, and the kinetic energy of the other part will be what? Okay, so one part is 3 kg. So other part have to be what? Have to be 9 minus 3, that is 6 kg. Okay, so it has a velocity of 16 meter per second, which is given. Now initially this big particle is in rest, so we can conserve the momentum, right? So initially it is in rest, so m cross 0, that is the initial momentum, and you can equate with the final momentum, which is 3 into 16 plus 6 into v. Let us say that the velocity of the 6 kg part is v. Okay, so let us think that the velocity is v for this. Okay, so we can calculate this by 3 times 16. What is it? 3 times 16, that is what? 32, 48. 48 plus 6 v. Okay, so 48 upon 6 minus, that is, so v is coming out to be what it is? It is minus 8. So this is in opposite direction of this block of this part, right? So since it is coming out to be negative, so now the total this is what is asked, right? The kinetic energy of the other part. So the kinetic energy will be E will be half into the mass of that part, that is 6 into the velocity square minus 8 square, right? So this is coming out to be, let us separate it, right? Half times 6 into 64. So this is coming out to be what? 64 times 2, that is coming out to be 128, and 128 plus 64, that is 192. Okay, so this is 192 joule. 19 joule is coming out to be my answer. So here option A is correct. Okay, you get it? Okay, so let's move into the next question. So this question is very good question, right? Very good question. So we'll solve this question. What minimum horizontal speed should be given to the bob of the simple pendulum of length L so that it describe a complete circle? So this is a bob. Okay, this is a bob and it is a string, and let's say this is something like ceiling or things like that. So this is suspending, this bob is suspending from that ceiling. So you have to find out the minimum horizontal force that should be given. Okay, so let's think that the minimum horizontal force that should be given is V. Okay, so V is the force that should be given so that it describe a complete circle. Okay, so when it will circle like that, right? This body will circle like that, and there will be a position, this bob will come to that position, right? Let's suppose that the size of that and this string is equal, because my drawing is not that good, so let's think about that, right? There will be a certain position here. Okay, so here let's say that the velocity of that bob is v1. Okay, okay, v1. Okay, so here if you calculate the force which will be act on that bob, there will be a force of gravity which is mg, and let's say that the mass of the bob is mass of the bob equals to m. Okay, so there will be a gravity force and there will be a tensile force which will be act toward the ceiling, right? And there will be a force which will be act to the upward direction, which is centrifugal force. Okay, and this centrifugal force is acting due to the motion due to the circular motion. So if we equate those three forces, we will get mg plus t plus half, no, this is not half, right? This is m v1 square upon this length, which is given as L, right? This is given as L. Okay, so this is the equation we get. And again we can compare it by the energy system, right? So let's say this is the zero level of potential energy. This is the zero level of potential energy. So initially the bulb has a energy of half m v square, and at that position the total energy will be what? Half m v1 square plus there will be some potential energy. So what is it? This is mg into the total height. Mg into what is the total height? Here it is L and here it is also L, so that will be 2L. Okay. So this is coming out to be m cancel out. Okay, so v square equals to v1 square plus 4lg. Okay. Now if you look at that stuff, so when it will describe a circle, we have to find out the minimum velocity required. Okay, so when that bob will describe a circle, at that scenario the t should be minimum, and the minimum value of t is what? This is nothing but 0. So we can say that mg should be equals to mv1 square, sorry, this is v1 square upon L, and m cancel from there, and we'll get it as v1 square equals to gl. Okay, so if we put this stuff there, we'll get v square equals to gl plus 4gl, so which is nothing but v square equals to 5gl, so that is v equals to root of 5gl. So this is what I searching for, the total minimum force. So this is the amount of sorry, this is not force, right? The total the minimum velocity. So this is the minimum velocity required to this bob, so that it can describe a complete circle. Okay, so this is my answer. Now we will discuss the next question. Here it is given that a body, right? Not a body, a wire is suspended from a ceiling like that. Okay, and there is a body of weight 200 Newton is attached with it. Okay, so after attaching this body get slightly stretched, right? So it is given that it is stretched by a distance of 1 millimeter, and what is asked to, what we need to find out? We need to find out the elastic energy stored in that string after the body is get attached with it, right? So what do we know? Elastic energy is, so this is a simple formula which you need to know, right? Elastic energy is nothing but half into the force that applied due to the gravity of the earth into the extension, right? Extension in the string, extension. Okay, so here we can say that the total force is 200 Newton, right? 200 Newton, which is given already, and the extension is 1 millimeter, that is 1 into 10 to the power minus 3. So that is my answer. So this is coming up to be there, in not should be there, right? This is coming out to be 0.1 joule. So that's it, we have done it. So now let's see the next question. Here what is given is that there is a spring, right? There is a spring, and there is a block. Okay, and initially this block has a speed. Initially this block has some speed. okay, and it is approaching toward that string with some velocity. Let's think that the velocity of that string is v, and it has a mass of m, which is given in the question, and the spring has a spring constant of what? Spring constant of k. Okay, okay, and after collision this spring gets stretched, compressed by a length of L. Okay, so after collision what happened is, oh, so I'm just, okay, so after collision it is stretched by a length L. Okay, so let's think that the initially this string was like that, and after collision this string get like this. Okay, let's think about that. So what is the total energy stored in that spring after that collision? And that energy should be equal to the total kinetic energy of that block, right? So we can equate it like that: half k L square, that is equals to half m v square, right? Okay, so we can find out the value of v from there. V square going to be, so v going to be, so we get the value of the velocity, so we can equate the you can find out the momentum as well. Momentum is m. Okay, so that is in capital, right? That was in capital, so we have to do it in capital. Okay, and momentum is equals to v, m into v. Okay, and we find out the value of v earlier, so this is going to be, okay, there is also, it is in capital. Okay, this is also in capital. Oh, this 2 should not be there. What is happening? It is not working, right? Okay, anyway, just erase this. So this is coming out to be km into L. So this is the momentum, right? And this is given in the question in the option D. So D is the right answer of this question. Now we will see the next question. In this question, it is given that retardation is proportional to displacement. So what is retardation? Retardation is nothing but negative of acceleration, which is proportional to displacement, which is x. Okay, we can do it like, now we know that acceleration is nothing but v into dv dx. Now we can do it like that, and now we will do integration. Initially, let's say that this particle has a velocity of v1, and finally it has a velocity of v2, and initially it was in rest, it was in at a position of x equals to 0, so, and finally it was in x. So this is coming out to be v2 square upon 2 minus v1 square upon 2, and this is coming out to be what? Minus half mk x square Now if you multiply both sides with m, which is a constant term, you can do it like that. And let's say that the mass m is nothing but the mass of the particle. So this so what is it? This is nothing but the energy, right? This is the kinetic energy at the final position, and this is the kinetic energy in the initial position. So this is loss of kinetic energy, and this is proportional to x, as you can see from there. So this is coming out to be loss of kinetic energy is proportional to what? X square, and which is given in the option C. So C is my correct answer. Now next question, force component, force vector is given, and the displacement vector is also given. We have to calculate the work done on the particle in joule. Okay, so we know that work done is nothing but F dot r vector. Okay, now we will just dot product these two. Now by doing dot product we will get, this is what? This is 10, this is -3. So 7 joule is my correct answer, which is given in the question option A. So A is my correct answer. Now moving on the next question. So what is given in this question? There is a spherical ball of mass 20 kg is stationary at the top of a hill of height 100 meters. So this was a spherical ball. Okay, this was in a height of 100 meter. Okay, so let's think that that height is 100 meter. 100 meter. Okay, okay, this height is 100 meter, right? And it rolls on a smooth surface. It is a smooth surface. Okay, it is a smooth surface. Then it climb up another hill of height 30 meter and finally rolls down to a horizontal base at a height of 20 meter above the ground. Then it climbs up another hill of height 30 meter. Okay, so height of this is 30 meter, which is given. And then it is again climb a height of 120 meter, and it is a base, right? So this is my 30 meter height, and this is a height of 20 meter. Okay, so we can conserve the mechanical energy from there. So here we have only potential energy, which is m into g into h. H is what? H is, so mgh. So this is equals to, let's say this is potential energy. Okay, mgh, this is equals to 20 into g into what? Into 100. This is a total potential energy, and the total energy, you can say the total energy, right? This is the total energy. Okay, and at that position, that total energy should also be uh, true for this. So here we have potential energy as 20 kg plus 10 into the height, plus there will be a kinetic energy. Okay, this is the kinetic energy, and it is equal to be the total energy at that position. So kinetic energy is coming out to be what? 20 into 10 into 100 minus 20 into 10 minus into 20, right? So this is coming out to be what? 20 into 10 into 80. And we know that kinetic energy is half m v square. So 20 into 10 into 80, and m is given as 20. Okay, so half into 20 into v square equals to 20 into 10 into 80. So 20 cancel, and this would be what, v square will be, so I am just writing there v square going to be 6 16 1600, right, 00. So v should be equals to 40. Okay, so b is my correct answer. Now moving on to our last question. So this is the last question. Here it is given that a body of a particle of mass 1 kg is moving with the moving along the x direction, right, x axis, and the potential energy is given by that equation, Vx equals to x to the power 4 upon 4 minus x square upon 2. Now we can differentiate it with respect to x. So this is coming out to be like this, x cube minus x. And for minima or maxima, we can do it like dv dx equals to 0. So we'll get x cube minus x equals to 0. So x coming out to be plus minus 1 or 0. So the minimum potential energy coming out to be at x equals to 1 or plus 1 or minus 1. This is 1 upon 4 minus 1 upon 2, right? So this is what, this is minus of 1 upon 4, and it is also given that the total mechanical energy of this particle is 2 joule. So total energy equals to PE plus kinetic energy K. Okay, so when K is maximum, PE should be minimum. So what is the value of PE at the minimum position? So 2 equals to PE minimum and KE maximum, because when PE is minimum, the potential energy is minimum, the kinetic energy should be maximum. Okay, and PE minimum is 2. So this is my maximum kinetic energy. Okay, we are just now we are doing it here. Okay, we are doing it here. So this is max KE max equals to what, 9 upon 4. Now we can find out the velocity from there, which is half into the mass, which is given as what, 1 kg. 1 into velocity square, that is equals to 9 upon 4. So this is coming out to be, so v square equals to 3 upon 2. So this is asked in the question. So A is my correct answer here. That's it for today. Thanks for watching. So stay safe and stay home. And if you found this video useful, give a thumbs up. And if you wanted to see more educational video like this, so do hit that subscribe button. And if you have any comment or if you have any question, then feel free to leave it down in the comment section, and I'll try my best to address them. So till then, bye.